So. Thank you again, everyone, for being here. Tonight's presentation will be on finding and fixing leaks in your irrigation system. And tonight's presentation is also part of Zero Waste Week. So that is why tonight's webinar is called Zero Waste Water, on eliminating water waste in your yard. Tonight we are joined by Chris Loomis. And Chris is a senior program specialist in water use efficiency at Sonoma-Marin. She is a certified irrigation designer and landscape irrigation auditor through the Irrigation Association, and is a certified qualified water efficient landscaper and quail instructor. Chris has over 25 years combined experience with landscape and agricultural irrigation, conservation, and teaching landscape irrigation courses. Chris has worked with the landscape and agricultural irrigation business on the supply and design side. She is also an adjunct instructor teaching landscape irrigation and quail courses at community colleges in Sonoma and Mendocino counties. She enjoys transforming complex terms into digestible information and helps students to grasp technical terms. Chris loves to nerd out on irrigation and get to the bottom of things. So thank you so much, Chris, for being here as one of our irrigation experts tonight. And we're also joined by Leslie Hart, who has lived and gardened in Sonoma County for almost 30 years. Moving to the hills above Sonoma as a newlywed, a friend helped her with her very first vegetable garden, and she discovered irrigation and deer and gophers. Leslie now lives in Pengrove. She incorporates native and water-wise plants into her landscape, as well as growing vegetables year-round. She especially enjoys figuring out how to best irrigate the many different sections of her garden efficiently and according to their water needs. Retired after many years of teaching high school chemistry, Leslie has been a master gardener and garden sense consultant since 2017. She is currently the coordinator for the Garden Sense program. Welcome, Leslie, and thank you for being here with us.
Thanks, Lauren.
And my name is Lauren Lum. I am a program specialist with Sonoma Water, and I will be your host tonight. And thank you all for being here. So again, tonight's webinar is part of the Zero Waste Week, and there are many more events happening throughout Sonoma County this week, all aimed at ways to reduce waste in your life. I think tomorrow, for example, there's a composting workshop, and the Master Gardeners are hosting a food preservation workshop. So a lot of great events happening this week. So if you haven't checked out the Zero Waste North Bay website, the link is there, and I'll put it in the chat, which reminds me that I was going to use the chat to utilize like our, put all of our resources. So I will work on enabling the chat so that you all can see it.
We've got it working now, Lauren.
Oh, okay. Okay, great. Glad to hear it. And yeah, so I'll be putting resources in the chat, and then the Q&A will be utilized for questions, where you can put questions to our panelists, and that is where we are going to pull for the Q&A portion of tonight. And before we get started, we're just going to do a quick poll asking if you currently have an irrigation leak, and if you hire someone to manage your landscape, or if you do it on your own. So if you could just take maybe 30 seconds to answer our poll, that'd be really helpful. Thank you. Great. I'm gonna go ahead and end the poll. So it looks like majority do not currently have a leak, but there are a few that do. And most of you manage your landscape on your own. So thank you for participating. That really does help us to gear the presentation towards the resources that you need. And with that, I'm going to pass it off to Chris. Oh, actually, first, I do want to mention that we are giving away an irrigation repair kit. And so in order to be entered to win, we'll be raffling off 3 irrigation repair kits. And I will share the link, the entry link, so that you can be part of the raffle. And you must be present to win. So please do stay until the end, where we will announce the raffle winners. And with that, I'll pass it off to Chris.
Great, thank you, Lauren. First, I want to start off with a few slides talking about our current water supply and why saving water is important. So in this graph, you may or may not be familiar with it. These are our 2 main water supply reservoirs in Sonoma County, Lake Mendocino and Sonoma County. And we are in our 3rd year of sustained drought, and the 2021 water year was equivalent to 1976 and 77 drought of record. I'm not sure where you guys were. I think I was in 1st grade, so I probably wasn't paying too much attention at that time, but just to give you just an idea, it's been a long time since that happened. So this is pretty unprecedented. This is historic lows. And as you can see in these illustrations, that 2022, we are at 61% of our normal supply for this time of year. In Lake Sonoma, we are at 52. Compared to last year, we are quite a bit better off at Lake Mendocino, but not quite that much better off for Lake Sonoma. So if we have another dry year, this will also be more concerning as we go forward. Next slide, please. And this is a map of California and the current drought conditions. So where we are over on the leftist coast here, you can see that it's that orange color, which is D2, which is considered a severe drought. And this is something that you can keep track of yourself. The link is at the bottom of the page. We can also, we'll be following up later to give you some of these links in a follow-up email later on. So you can see where we're at. It's a good idea to keep taking a look at that as we go. Next slide. And then as of last July, the governor made an executive order, which included a lot of simply common sense actions to save water, but also asked Californians to reduce water by 15% from their previous year. And some of those common sense ideas are reducing your outdoor irrigation, just running full loads of laundry and dishes, finding and fixing leaks. Thank you all for being here tonight. Installing high efficiency fixtures, including toilets, shower heads, faucets, replacing those old washing machines that are top loaders. And then capture and reuse warm up and rinse water from your kitchen faucet and also your showers while you're waiting for that hot water to arrive. Next slide. This is a graph that's a little busy, but for me, it's really impactful to take a look at this. This is where we're at right now compared to his previous years. This black dark line is where we're at right now in the current year. And the main thing to pay attention to is it's one of the lowest lines on this chart, which means that our water supply is lower than any of these other previous years that we've had. It's kind of neck and neck with last year, which was 2021, and that was a pretty scary time. So we're a very similar situation as we were last year. Hopefully, when the spring gets here, we'll have some like we did back in 2019, where we have a little bit of extra to spare. But for now, check in on this website anytime you want to see how we're doing, and hopefully you'll see this line go up instead of down. Next slide. Okay, so now what we're here for today is you think you might have a leak, let's find them and fix them. Next slide. So first things first, what you want to do is make sure that before you go out to check for leaks is that you have nothing running in the house as far as water using fixtures. No showers, baths, faucets, toilets. Some things might not be as obvious, like maybe you start a load of wash and you forget about it. So washing machine, dishwasher, irrigation system, the water heater, maybe after you've taken a shower, takes a minute to fill. So you've got to make sure you give it time. Water softeners, swimming pool filters, ice makers, evaporative coolers, your snow blowing machine. Okay, so no, I'm just kidding about the snow blowing machine, but the point is there's a lot of water using fixtures that we have in our homes and our landscapes, so we have to make sure that nothing's running before we take the next step. So now let's get to finding your water meter. So where is my water meter? Okay, so here are a couple of things that you're going to be looking for. You're going to be looking for boxes out in front of your house that say water or meter or something on it. And the two different boxes that we show on the left are handy meter reading lids. So when people go around and actually check meters physically, they're able to lift that little lid up and read what's inside of your meter. So where is it at? So here I went to Google Earth and I drove around the street virtually, and I found all of their meters in front of their houses, and I saw what kind they were. So I marked that they weren't all the same. So the point is you're not always looking for the same kind of box. You may have a different kind of box you're looking for. So usually it's right in front of your house. Sometimes when they put meters in, they put them in side by side. So you may have two meters right next to each other. So make sure it's your meter and not your neighbor's meter. You can usually tell that by the serial number on the meter. Next slide. Okay, so now you find your meter and you go, oh, whoa, okay, so now what am I supposed to do? So you open up the lid and you see this dirty mess in here. So the point is, try not to get too intimidated by this. You know, there may be some bugs and spiders in there, but if you can just kind of sweep that off, this next step should be pretty easy. So now you have the dirty, yucky meter, and then on the right you have where you've kind of dusted it off a little bit, and now you're looking at something that looks kind of like an odometer. Next slide. Maybe your meter box doesn't look like that. Maybe you have a meter box that has this little plastic bubble on the top. That might mean that you have what we call advanced metering infrastructure, or AMI. And that's something where the communicating is going on behind the scenes, and nobody actually, you know, raises up the meter box to see what your meter read is, or drive by to check it. You can still check your meter with one of these. You do have to use some extra caution when you're opening the lid so that you don't damage any wires in there, because they're usually attached to the lid. And then if you do have one of these meters, yay, okay, this is great. AMI is a great tool to find leaks and monitor your use. So you want to check with your water provider if you do have one of these, and see how you can sign up for their portal access so that you can monitor your use and figure out if you have a leak that way. Next slide. So once you've got your meter box open and you're looking at it, what are we looking for here? So not all meters are the same. So if you want to see if you have a constant leak, you go out to your meter and you take a look at the leak detector on these meters. So I have all these arrows pointing to different leak detectors. So it takes more water for the dial to turn than it does for the little leak detector. So the leak detector sometimes will just move very slowly. Sometimes it's more of like a ticking motion that happens with this. So you want to keep your eye on that. Sometimes it happens really slow. So I like to use my camera and take a picture of it to see where it is. Wait a minute, take another look, see what's going on. Sometimes it's moving a bit faster and you can see, you know, the numbers actually changing on your meter. And, you know, sometimes they look like a little triangle. Some of them look like a gear. I exploded the visual of the blue gear because I think it kind of looks like a turtle, honestly. I think it looks like it has a little turtle head. And so it's a little bit different, so you could really tell where things are. And then if you have a digital meter like the one down on the bottom left corner, you'll see like a plus sign. That'll also give you an indication of what the actual flow gallons per minute is. Okay, next slide. Okay, and so what kind of leak do you have? So there's different kinds of leaks. So if the leak indicator is moving when you check it, then you have a constant leak, or you happen to catch it right when the thing that's leaking is leaking. So if the leak indicator is not moving at the meter, you might have a periodic leak, like maybe you have a toilet flapper that leaks, and then it will fill the toilet periodically. You'll hear it running, but it's not always running. So that might be a periodic leak. You may have a leak in your irrigation system that only reveals itself when it's turned on, when it's actually running. Like you go outside, you see evidence of a leak, and you check your meter and it's not moving. Doesn't mean you don't have a leak. It means you don't have a leak right at that moment. But when you turn your irrigation on, you might. So you have to, and then the other thing is you might not actually have a leak. You may have some drainage issues with your irrigation system. If you have any slopes, a lot of times when the water shuts off, it'll sit down at the bottom of a hill. you might see a puddle and think it's a leak. It's actually drainage. And that's another problem that we have to look into. So the next step is to isolate the problem. Next slide. Thank you. So if you're on a well and you don't have any of these meters and you're like, okay, this doesn't even apply to me. I saw several people that are here today that have a well. Well, it's not all lost. There are some things that you can do. Most of what we're talking about today is not having to do with a well, but we're not going to leave you out. So if you're on a well and you suspect that you have a leak, you would still do the same process of making sure that all of your fixtures are off, nothing's running. And then you're going to go out to where your pump equipment is located and listen. Bring a chair, sit down for a minute and just listen and see if you hear anything. Also wait to see if the pump is cycling. Do you hear it, you know, kicking on and off? There's usually pressure gauges out where your pumps are, and see if those gauges are moving. Like, take a look at what it says when you get there and then see if it dips down and starts losing any pressure while you're there. And that could tell you that there's something going on somewhere. The other thing is, consider installing a meter so that you can make it easier. You don't have to be getting your water from a municipality or a city to have a water meter to be able to keep track of what you're doing. So you might want to install a meter. We're going to be talking about a product called a flume in a little bit, and that's a product that you attach to your municipal meter, and it keeps track of stuff for you and will send you alerts on your phone or on your computer and tell you that whether they suspect a leak or how much water you're using. And if you do decide to install a meter, you could install a flume as well. And if you want to talk more about that, there's my email address, which will pop up again at the end of the presentation, and I can try to get you pointed in the right direction. Next slide. Okay, so why would you want to monitor your home water consumption? It's for not just leaks. So if you are suspecting that maybe you're overwatering, it's one way to keep track of how much water you're using by checking your meter before and after your irrigation runs. And if it seems like an enormous amount of water, well, maybe perhaps it is, and it can help you kind of get that dialed in. It can also help you figure out, like, you know, do you have efficient equipment in your house? Are your fixtures efficient? So you could read the meter, go do a load of laundry, and then go back out and read it again and see how many gallons that you've used. And if you have a top loading machine, I can already tell you you're going to be a little surprised by the number. You're probably using between, you know, 30 and 50 gallons a load for every load of laundry. So if you want to know how you're doing, or, you know, how long is that 20-minute teenager shower actually using up, you could actually read your meter to figure that out. So how do you do it? You go out, you read your meter, you use some of the tools that are available from your water utilities. If you do have the AMI type of meters, North Marin Water District, Valley of the Moon Water, City of Santa Rosa, and Marin Water does have some of their meters on AMI. Other utilities are on their way. Sonoma's on their way, Windsor's on their way, and you'll have these tools at your fingertips to be able to see how you're doing. And I'll show you an example in just a minute. I also have an image here on the bottom right corner of an irrigation flow meter. That's another way that you could install a meter that the city is not reading, but it's for your benefit so that you can hook it up for your irrigation system. So you can keep track of your irrigation use outside separate from your indoor use. And then also you can use an app like the Flume. Next slide. So what does a portal look like? So this is, if you are a Valley of the Moon customer, they have launched their portal, and this is what it looks like. You can go on there and check out what's going on by the hour. You know, how much water did you use the last hour? You can also check and see if you have a leak. And this particular hourly water usage report indicates that there is a leak of almost 100 gallons an hour. So 100 gallons an hour sounds like a lot, but it can sneak by and go undetected very easily. So you want to get to the bottom of it and figure out where that is. Next slide.
And Chris, someone in the Q&A has asked, what is AMI?
Okay, so that's automated metering infrastructure. And that is where it is connected digitally to your water provider. So they know hour by hour, some minute by minute, how much water you're actually using. So it's a helpful tool. So if they detect a leak or see some anomaly, they can let you know. But this is a tool that you can also look at. And if you look at this report, you can see that, you know, all the way down at the bottom of the page, it's like 11 p.m., then midnight, then 1 o'clock in the morning. You can see these leaks happening. And that indicates that there's a problem. Normally, if you would see in the middle of the night, nothing happening at all, or maybe a toilet would be flushed or something like that, but nothing near 100 gallons a day or gallons per hour. So this is also on the portal where you can check and see how you're doing. This happens to be an hourly graph, if you like graphs better than spreadsheets. And it shows you that this particular household used most of their water between it looks like the hour of 10 and 11 a.m. in the morning. And then the rest of it is pretty flat. You can see on the left-hand side that that's in gallons from 0 to 40. So my guess is somebody was doing laundry or irrigating during that time. Next slide. And then this shows how you're doing compared to other people. So that little blue dot is you. And then the average household is the grayed area. And then the most efficient is that blue line. So whoever's water usage this is, they're doing a great job because they're only using about half of what the most efficient person uses. So you can pat yourself on the back hopefully you can pat yourself on the back if you look at this page. Next slide. Okay, this is a great image of what a seasonal usage looks like. So this is someone that has had, AMI data for almost a full year. And you can see that this illustrates consumption is the aqua colored bar, precipitation is that dotted line, and average temperature is that sort of beige sort of color. And you can see that this particular household does a pretty good job at following the curve of the average temperature, that when the temperature is higher, their water usage is higher because it looks like obviously they're irrigating. When you get into the months of November, December, January, February, you can see that that usage drops down quite a bit, indicating that that's how much water they use indoors. Next slide. So other ways that you can monitor your use if you don't have a utility provider that has AMI metering is you can look into purchasing something called a flume. This is a smart watering device that you attach to your own water meter. It gives you real-time water use, and as far as like gallons per minute right now, how much water is being used, how much has been used every hour, how much has been used every day, every month. And you can set parameters so it'll warn you if you reach a certain limit. So in the cities of Healdsburg, Marin, and North Marin, they provide reduced cost or rebates for these flumes, encouraging people to get to put these in and become more in tune with what their personal water use is. So the flume device is only for residential municipal water users or smaller meters, or you could use them if you're a well water user and you purchase a compatible meter to go with it. And again, you can contact me and I'll give you some more information. There is the website down at the bottom of the page, and we can include that in our follow-up email for you to check it out. Okay, so what does it look like? This is what comes in the box. On the right-hand side, that's called a bridge. That's what receives the data from a radio frequency from the sensor that's connected to your meter, and that stays inside your house within communication ability of your router. And then on the left, that is the data sensor that you install in your meter box. And it converts information from pulses to quantifying how much water is being used, and it transmits that data to the bridge. Next slide. So this is what it looks like when you install it inside of your valve box. So the image on the left is just kind of showing the scale of how big that is and where I've got to put it. And then the image on the right-hand side is actually the flume at my house that I've installed. It is very easy to install. It basically has like a rubber band around it, and you just put it around the register of that meter. And how it works is as the meter is working, it has a nutating disc, or just a disc in it that twirls. And when it twirls, it sends a pulse. And this flume device can capture that pulse. And since you tell Flume what meter you're using, it knows what each pulse means. And then it translates that pulse into how much water you're using so that you can keep track. Next slide. And this is what the portal looks like for a desktop user for the Flume. This is actually my data, but you can see that I just put it in last June, so I don't have a lot of data from the previous year, but this shows you how many gallons and then tells me how I'm doing on my budget, you know, that I've used 78% of my budget, my weekly budget, my monthly budget, that I'm doing really good on how much water I should be using. But this is a great way to keep track of yourself. So it looks like July, I'm kind of neck and neck. I'm hoping that I can keep that number down for the rest of the month. Next slide. Okay, and then this is how you stay informed. These are alerts that will pop up on your phone. You can get alerts that tell you like, hey, you're getting kind of close to your daily budget, and the daily budget is something that you tell it what you want to use. So for instance, last year when we were having some water shortage issues in Healdsburg, we were put on a budget of 74 gallons per day per person. So I did the math of like, how many gallons does that mean? And so then I put that in as a water budget for our family, so we would know if we ever got over that. So the only time we ever go over that is, well, now that I have a daughter that's moved back into the house, every once in a while on laundry day, we might go over that budget, but we're pretty good otherwise. And so it shows you that you've reached 70% of your budget, 80% of your budget, 100% of your budget. And then the other warning is that you have a leak. So if you thought you turned something off, but you didn't, then your flume will tell you like, hey, you've had some water running for like 2 hours now, what's going on? And so it'll let you know. And it's also good, like if you're out of town and there's a break or something like that, it'll let you know. Okay, so now how do you find the leak? So you've got to isolate the problem by turning off valves to determine if the leak is indoor or outdoor. So first you want to check the meter and see if so you want to turn off the valve that you think is going to help you out figuring this out. So then you check the meter again, and is the leak indicator still moving or not? So if the indicator is no longer moving, you're one step closer to finding the leak, because now you've isolated it because you shut it off. If the leak indicator is still moving, then the area that's controlled by the shutoff valve is not the problem. You have you have a leak somewhere else. So there is a possibility that the leak could be in your main line, your main water line, between the meter and the shutoff valve. So keep that in mind if you can't really narrow it down, that could be one of the issues. So then you want to test your indoor water fixtures to see if they're shut off. So you can figure out, well, what did I just shut off? If you're not really familiar with the shutoff valve and what it does, you need to figure out, did I just shut off the indoor? Did I just shut off outdoor? What did I just do? So you need to check your fixtures to see if they're working. So same goes for outdoors. And then that will, these are the steps to help you narrow down the leak, whether it's indoor or out. Next slide. So if you have determined that the leak is not outdoors, or you suspect you might have a toilet leak, this is how you can do it. Feel free to zap that QR code, or otherwise you can just go to the partnership website and get these instructions. So the first thing you want to do is you want to take the lid off of the back of your toilet, and then just listen and put your ear down and see if, or hear if the valve is running and filling the toilet. If the valve is running, then the dye test isn't going to do you any good. You need to repair the toilet to ensure that it shuts off completely. If it is not running, then go ahead and do the dye test. So you can either pick up dye tablets at your water provider for free, or you can just use food coloring. So in this case, we're using food coloring, giving it a few drops and waiting a little bit. Next slide. So the next slide is the results of the toilet leak test. So on the left-hand side, there's no color in the toilet bowl after 10 minutes. That means there's no leaky flapper. If there is color in the bowl, like the image on the right, after 10 minutes, then you do have a leak. So if there's no leak, the next step is to investigate where else the leak might be. So for some ideas on where to go, I'm going to show you, there's that link at the bottom that we can share with you. And then also, if there is color in the bowl, you need to look into, of course, repairing the toilet. Likely it's new flapper, and we do have some links on how to find that too that we can share with you in a little bit. Next slide. This is a checklist for helping you chase down leaks from the EPA. And you can zap that QR code, that'll take you there. Otherwise, you can go to our partnership page and find this. This kind of walks you through what we've been talking about, but where you can try to find leaks. Next slide. Okay, so is the leak outdoors? What am I looking for? So what you want to do is you want to stop look and listen for leaks. Leaks are not always visible. You can't always just see them and know, oh, well, there it is. Sometimes there's other signs for leaks. Water hammer. You might hear pipes banging around under the house when something shuts off. That indicates that something's flowing pretty darn high and it might need to be looked into. So if you have a leak in your irrigation, that could be an indication with water hammer. If you hear fast spraying sounds up against something, you hear muffled spraying sounds. Sometimes this might be squirting underneath mulch and you can't quite tell where it is. You got to just snoop around. If you see water gurgling from under the soil or the mulch, or of course, if you see water dripping. And of course, trust your gut. If something does not feel right, sound right, look right, it probably isn't. So you should just keep digging deeper. Next slide. So there are some sneaky and some not so sneaky clues of leaks out in your landscape. So water spraying, puddles, wet or soggy spots, really green areas because they're getting a little extra water. Water stains, is there runoff going down the street? And is there water collecting by sprinklers or low spots in your landscape? Next slide. So here's a couple of examples of sneaky versus not so sneaky leaks. So on the left-hand side, we have water draining out of this backflow preventing valve, anti-siphon valve. And also when that happens, that's normally because the valve has been installed in a lower place than where the water is going. So normally these valves need to be about 12 inches higher than the highest outlet they serve. So if you have irrigation that goes uphill, when it shuts off, water can drain out of this cap, and that means it's actually doing what it's supposed to be doing. So the question is it leaking when it's on or is it leaking when it's off? So we'll get to that in just a minute. Also down on the bottom left-hand corner, that's a valve that's been installed improperly. That valve is supposed to be, like I said, about 12 inches or so according to code, or check your local code. And so if it's not 12 inches higher, when the valve shuts off, the water tries to go back to where it came from and will gurgle out of the top of that valve. So you may see some wet spots around that valve. Then the not so sneaky on the right-hand side, obviously that anti-siphon valve requires a repair. On the bottom of the right-hand screen, I'm showing you basically what the components of that side of that valve is. There's only two pieces inside of there. So if that's happening, it's likely that the piece that the arrow is pointing to is bad, or it's dislodged, or something's wrong with it, or the washer's worn out. But make sure you have your water turned off before you open these up, or hire a pro if you need help. Next slide. Okay, and so then sometimes you're wondering, well, is it really leaking? Because I don't see anything happening, or I might only see a wet spot. So this is kind of a hard picture to see, but on the left-hand side, you have these innocent looking irrigation valves. But then in the middle, we went ahead and we knew something was leaking. So we took the caps off of the filters to see, well, which one is it? That will speed up the process. So you can see where the arrow is pointing in that, at that valve was actually leaking. There was some crud stuck inside of that valve. So we needed to open it up and clean it. So that's one kind of way that you can narrow it down to what's happening. But we weren't able to hear this leak. We were only able to see it. Next slide. Okay, so this is a not so sneaky repair. This was one that you could hear for sure. It's kind of hard to tell on the left-hand side, but there's water spraying really fast and hard out of this fitting. And where we have it circled, this particular fitting was installed and it cracked. And the reason for that is you shouldn't install female plastic onto male metal fittings. And that's what happened in this installation. And eventually it'll crack, not the first day. It'll only crack when you have your back turned and you're doing something important. So that's a leak that was not so sneaky. Next slide. Okay, so here, this is where we have replaced that valve, or excuse me, that fitting. And we are showing you where the shutoff valve is. Next slide. Okay, this is another sign of some leaks. If you have anti-siphon valves and you have any moss growing around them, or green stuff, or vines trying to grow up inside of your valves, that's a pretty good indication that that valve might leak, either all the time or at least for a while after it shuts off. And then the valve next to it has no obvious signs of leaking. Next slide. Other signs of leaks, you might see that you have a wet fence and go, okay, why is my fence wet? Okay, well, if the system's off, you're not going to know. Another sign on the bottom left is pooling water around a sprinkler head. They may not all have water around them. It might only be one. Next slide. So if it only leaks when it's turned on, it's still a leak, right? So here we have the system off on the left-hand side, and we've turned the system on the right-hand side. So the point of this is to show you that sometimes you need to catch these leaks red-handed, right? You need to go turn on the valve and see what happens. The wet fence is one thing, but figuring out where it's coming from is another. Next slide. Okay, so now we're going to head out into the landscape with Leslie and see, figure out how do we tackle this. So what components am I looking for? What do they do? What goes wrong with irrigation systems? How can I avoid these mistakes? How can I fix it? And if I don't want to do it myself, is there help out there? So Leslie's going to take over now and finish us off.
Thanks very much, Chris. Before we talk about specific examples that commonly occur in drip irrigation, let's list everything that is in your system. The components with asterisks next to them are all potential sources of leaks. The valves, as Chris has been talking about, hose bib assemblies, filters, distribution and drip tubing, emitters, and fittings. The other components may appear to have leaks, but the problem is something different, or provide you with clues that you have a leak, as Chris talked about. I'm going to focus on tubing and the related components, the items that are in orange here on this slide. Next slide. We recommend that you check your irrigation lines regularly, once a month at least. If you can, physically pull up the line so you can see leaks. Your ears are your best tool. Last week, I was out in my garden when the irrigation system came on. I could hear that there were problems. I found 3 different leaks in 1/4-inch tubing in one part of the garden, and elsewhere I found a leak in 1/2-inch inline drip, and I'm going to show you some of those here. Your eyes are also a good tool, though so many leaks are hidden beneath plants and beneath mulch. Be prepared to regularly make repairs. Have the following on hand, and you can see that there are snapshots of each of these on the slide. Flags are something that I've really only come to use very recently, and I'm going, where were you flags all my irrigation life for the last 30 years? So useful, instead of trying to put a rock or something there to indicate where your problem is. 1/2-inch and 1/4-inch distribution and inline drip tubing, fittings for that tubing, so both for 1/2-inch and 1/4-inch, and including Goof plugs. You also need suitable tools to cut your tubing and to punch holes in the 1/2-inch distribution tubing. Don't forget the staples. They are going to anchor your tubing, and your tubing might be quite stiff if you're having to replace it. And so staples are really important. And those same size staples that come in big bags of 100 or so work for both 1/4-inch and 1/2-inch tubing. So they anchor your tubing and stabilize your irrigation system. Next slide. To encourage you, we are giving away a repair kit this evening. Chris, would you tell us about the components in this kit, and then especially your tool?
Sure thing, Leslie, thank you. Okay, so this is just a very simple kit that we have put together mostly in my mind, when I go out and I find an issue and I have to walk to the garage to get parts, it's usually one of these things that I need. One is I need a flag so I can put the flag down, go to the garage, get the part so I remember where it was, right? So what you want to do is you need to use flags to identify where the problems are. And then we have 3 of these brown couplings on the left-hand side, and those ones are fairly universal. Not all drip tubing is the same size. So we want to make sure that you have a coupling that will fit the size that you have. We also, on the right-hand side, we have the some drip emitters in case you had one that popped off. These are really high quality drip emitters that you can replace them with. Then we also have some Goof plugs down there. And hopefully a Goof plug will do the trick, but if it doesn't, don't be afraid to cut it and use a coupling instead. And then we have a hole punch. And then the tool in the center is a tool that I developed after being tired of not being able to figure out how much water pressure you have in your drip system. So it used to be kind of tricky to do that. And now I have built this tool so to make it easier for you. So basically this tool has a rubber tip and you can fit it over the outlet of an emitter or an emitter tubing, and it will give you a pressure reading. And so if you have a leak somewhere, it's good to figure out how much pressure you have at the beginning, figure out how much pressure you have at the end. And if there's a fairly decent difference, then that will indicate a lot of times that you do have a leak. And then you work backwards from emitter to emitter until you find where that pressure difference is really happening, and then make your repair.
And I think there's a picture of that on the next slide.
Oh, yep, there it is. So yeah, here we have, I have a sample tube with a bunch of different style emitters on there just to show you that you can use it on many different items. And the one that I'm using it on the left that's yellow, that's like a flag emitter, but it would work on any of the emitters that you see in that picture. Also on the right-hand side, this is where it's being used in the end of a drip line. It doesn't fit in all of them. In this particular one, they put a coupling in it so that it would fit, and then they were able to see how much pressure they had at the end. So those are a couple of different applications that you can use it.
And I actually have used it when I was putting in 1/2-inch inline drip to see how long I could get away with, well, how much tubing I could get away with. So I kept measuring it as I continued along my installation. Next slide. And so on the next slide, I'm going to focus on leaks and repairs of drip irrigation in both 1/2-inch and 1/4-inch tubing, and a little bit about point source emitters, which a lot of people call button drippers. A reminder, don't forget, turn off the water before making your repairs and after you have marked the problem with a flag. Let's begin with 1/2-inch tubing, that black distribution tubing that's used for everything in drip irrigation. Here is an example of lawnmower damage of this tubing. You can see how this leak is somewhat invisible in the left-hand picture. So the green weeds nearby are a good indication that there is a leak. This leak was caused by mowing the winter grass and was not noticed until I turned on my irrigation in the spring. My husband and I let our grassy areas dry out in the summer. The green patch of weeds helped alert me that there was a leak. And Chris and I both talked about how great flags are in order to identify where your leak is located. So I put a couple in here, basically on both ends of the damage. In this case, the lawnmower had caused too much damage for a Goof plug. So I cut out the tubing at both ends of the leak and then put in one of those straight power lock coupler fittings. And that provided for a very easy repair. Next slide. Here is an example of Gopher damage of 1/2-inch inline drip tubing. This leak was hidden under a fruit tree and found first by following the sound of rushing water. Again, hearing is such a useful sense when you are a useful tool when you're here looking for leaks. Upon closer inspection, I found muddy ground with a pool of water, and so that made the location of the leak obvious. I used the same type of fix as for the previous situation. In this case, the damage was in the area of an inline emitter, so the whole section that included that emitter needed to be removed. I used a straight coupler in order to repair the leak. Note that this is a brown in color, and it's designed specifically for this 1/2-inch inline drip tubing. Unfortunately, different manufacturers design their tubing with slightly different diameters. So 1/2-inch doesn't mean exactly 1/2-inch. Note that these brown power lock fittings will also fit the common black tubing. And so these are the types that are in the repair kit. So it's not so easy to go the other direction to use the black couplings on brown tubing, though you can make it work if you need to. Now, if the number of emitters around this tree was super critical, I would have added a section of inline drip with an embedded emitter to get the number of emitters back to what it should have been. And then use 2 straight couplers, one on either end of the repair, kind of a type of splice. Next slide. Here is another example of human-caused leaks. In the left-hand photo, you can see marks from a cultivating tool in the tubing. The sound of rushing water and visible spray were the clues that there were problems. This is also a reminder to be very careful when you are working with plants in an area where mulch covers the drip tubing. Expose the tubing if possible to save that tubing from your tools. Use the same repair method as for the previous examples. Cut out the damaged tubing, reconnect with the power lock fitting. Splice in a new section with embedded emitters if you need to do that. Next slide. Let's switch our attention to 1/4-inch inline drip. Leaks can be harder to find since many are of like a pinhole size. The first clue in this example was the sound of spraying water. But the leak itself was quite hard to find. And I'm not sure that you can see it in the photo. So if you're looking closely at your computer, look on the left-hand picture and see if you can find it. And even in this magnified photo, it's hard to see that it's a very fine spray. It's located underneath a plant. And so I had to search, move the branches apart and so on to find it. Who knows what caused this leak? So you treat and repair this similar to what you do for 1/2-inch tubing. Cut out the damaged section and connect with a straight coupler. If the leak is too close to an embedded emitter, as it was in this case, you need to cut the whole emitter out in order to leave enough room for the barbs on either end of the connector to securely install. You may need to splice in a section which contains an emitter, just as for the 1/2-inch inline drip. Same principle. Note that in both of these last 2 instances, and I think I've said that, you want to add back an inline emitter. So let's go on to the next slide. So another common problem is connections related to fittings. In this example, 1/4-inch distribution tubing has come loose. The first clue was the sound of rushing water, and you're undoubtedly hearing me say that often, and that really is one of your first clues. And this was in the other side of the garden. So I had to go searching. The damage was then obvious. I could see rushing water and wet ground. To repair this, I trimmed the tubing, then added a new straight coupler. A good way to reduce the possibilities of problems like this is to reduce the amount of 1/4-inch line and using a lot of fittings. It's just one more thing to come apart. So this is a great chance to use your imagination to come up with creative ways to efficiently use your irrigation components. After some time in your garden, you may end up with a Frankenstein situation following multiple repairs. In that case, it's often better to simply cut out a whole section and start again. And I did that again last summer in another part of this garden. Next slide. Gophers are rampant in parts of the county that have sandy or sandy loam soil. Gophers are presumably going for the water, and they've got such sharp teeth that they will cut right through 1/4-inch inline drip tubing. And I found their damage is typically on an angle, as you can see in the left-hand photo. In this case, trim the ragged ends with some type of a cutter or your pruners, and then connect with a straight 1/4-inch connector. So you have the idea here, you want to have plenty of these straight connectors available, both of 1/2-inch and 1/4-inch. They're probably one of the most useful components to have in your repair kit. Next slide. Pots. They are wonderful because they are so versatile and relatively easy to move. When you're setting up your pots, think about ways to minimize the effects of leaks. In the picture on the left, you can see a leaking shutoff valve, and it's hanging out there in midair. And there's another problem here, is that there are really too many connections. If you've got a large enough screen to look closely, you can see that this shutoff valve is sitting in the middle of distribution tubing, when a better place for it would be snugged up to the inline tubing and right inside the pot. Then you're capturing that leak, and you're also minimizing the number of connections. In the photo on the right-hand side, you can see that in this case, the inline drip, along with its shutoff valve, has been pulled out. And it's really easy to cause this problem yourself if you're moving the pots around. In this case, this pot was underneath another one, the canopy of another plant, and really wasn't initially easy to see, and it wasn't noticed. And here's another time where it's great to listen for leaks, and also to look at the ground or patio area around your pots. And this will help you both find any of these types of leaks, but also will tell you whether you're overwatering. Next slide. Looks like we jumped. There we go. Okay. Let's turn our attention to other important aspects of regular drip irrigation maintenance. So often we, or a landscaper, installs our irrigation, and that's it. We think we're done and don't have to look at it again. Unfortunately, our plants will outgrow their irrigation. Keep this mantra in mind. Grow your irrigation with your plants. This shrub has grown, and the roots are further out than when it was first planted. The irrigation is now easy to see because it is away from the plant. Half-inch inline drip is sturdier than quarter-inch. Note that there is an end cap rather than a T-fitting, and you can see that right where the circle comes back in. And is there a problem with the slides? I'm seeing the title slide.
Oh, just a second. Hold on.
We've got you doing a lot of work there. I'll keep talking.
No worries. Sorry.
So I like to put an end cap on the end of the circles rather than putting a T-fitting in, because then as the plant grows, it's really easy to add another section of the half-inch inline drip. However, if previous people have put a T in, or you prefer to use a T connection, you can simply cut out a section, or do a single cut and splice in some more emitters of the inline type on the other side of the circle. Now, to go ahead and update your drip, you will need the same materials that are in the repair kit that you've already put together to address leaks. A reminder that you want to move emitters away from the trunk or stems of your plants, and then increase the number of emitters as your plant grows. And there'll be more on this on the following slides. You also need to keep an eye out for clogged or leaking emitters in this situation. And Lauren, I could share my screen and run it from mine. Would that work?
Yeah, that might be helpful. Oh wait, I just got it up again. Sorry about that. Hold on. Let me just get it back to where you were. Sorry.
That's okay. So I'm at the regular maintenance of drip irrigation with some half-inch tubing, and actually we're ready to go on to the trees. Emitters too close to trees. Go to that one.
Just a second.
And so here in drought, one thing we've been talking about both in Master Gardeners and also Sonoma Water and our various municipal water utilities is the importance of prioritizing your trees. And so it's really important that you continue to water them. And in fact, the best is to put them on a separate valve, because they require less frequent but deeper irrigation. And there was a talk last week by one of our master gardeners, Linda King, about trees, and Lauren will probably put that in the follow-up. It was the climate forward trees, and she's nodding her head in follow-up. Yeah. So let's take a look at the trees here. Here are some common examples of irrigation that's too close to the trees. In the first example on the left, it's a little bit in shadow, but you may be able to see that the inner circle of tubing is far too close to the root crown. It's just about ready to choke it. And in this case, a way to fix that would be to remove that inner ring and then shut that off, so all you have is the outer ring. In the second example, although the tubing in this case is further away from the trunk of the tree, it's not far enough and the tree is grown, so it's not getting enough water. So this is a case where having an end tube on the end made it really easy to go ahead and put in a whole second ring and make a spiral around this tree. The outer tubing should be about a foot away from the inner tubing, because the emitters are about a foot apart on this particular drip line. And so you want your tubing to be a foot away, and then that means you are watering the roots right throughout that area. And the outer tubing should be approximately at the drip line of the tree. And what the drip line is where rainwater drips off the leaves onto the ground. So we're talking about drip line in terms of the type of irrigation, and now we're also talking about drip line in terms of the tree or the plants themselves. So let's go on to the next slide. Here are some diagrams that show this more clearly. You can use either inline drip, as you've seen in the previous slides, or point source emitters. But you need to remember to adjust the tubing and emitters as the tree grows. Place the tubing at the drip line and beyond. Some trees have even broader roots. Trees need to be watered deeply and infrequently, hence the need for them to be on a separate valve or zone. Trees are important commodities. They're long living, provide shade and habitat, and they're also expensive. So a reminder to prioritize them during droughts. And this is especially important if you decide you want to convert your lawn, which we want you to do, and convert it to low water use plants. It means that those sprinklers are no longer watering your trees. And you may not have been watering those trees deliberately while watering the lawn, but that certainly was one of the places they were getting their water. So if you do that, it's a good idea then to convert one of those valves that you no longer need for sprinklers to watering your trees with some drip irrigation. Next slide. Here's an example of how you can accommodate growing your irrigation for smaller plants, such as perennials or small shrubs. In this example, the point source emitters are used. In the left-hand photo, and I've put a box around it, and near the upper right-hand corner of that left-hand box, you can see a black emitter. And it is some way away from the plant that it is watering. And you can see that there is some 1/4 inch distribution line, otherwise known as spaghetti, that is taking the water from that emitter all the way to the roots of that new plant. So it needs to be watered more closely at the beginning. And then on the bottom right-hand side, you can see that that tubing is being trimmed because this plant has grown a little bit and now the roots are further out. So you don't need to have, and you don't want to have, the water right at the very base of the plant. And there's still another chance to go back a little further as this plant grows. Next slide. We use point source emitters to water specific plants rather than moistening the whole area. This takes some care and thoughtfulness to tailor the emitter placement properly. The emitter should be placed at least 6 inches away from the stem or trunk of the plant to prevent diseases and fungus attacks. The drawback of these emitters is that you have to expand your tubing configuration as the plant grows to match its root growth. And you have to remember to put in those emitters. Use the canopy of the plant as a guide, as you see in these diagrams and as you saw in the tree pictures. It's very easy to install and forget. And we in Garden Sense have seen emitters tied up at the base of trunks where their roots have grown around and through them after landscapers had put in the irrigation 20 years before, for example. Now, to begin with, a plant from a 1 gallon or smaller nursery container requires only one emitter according to this diagram. Well, we really recommend that you you want to circle that plant better with emitters. So at least 2 emitters, one on each side of a 1 gallon plant. When you get up to 5 gallons, two emitters for sure, and 15 gallon containers, at least 3. Next slide. Let's talk just a little bit about these slides that Chris showed earlier. And this is an example of a missing emitter, one that has popped off. Notice the wet fence. There is enough pressure to shoot this water into the air, making it easy to see if you are present, as Chris talked about earlier. Use the same type of method. You listen for leaks, and in this case, you can see it. You probably hear it banging against the wall, against the fence there. So look for it, flag in hand. Go ahead and mark it, turn off your water, and replace the emitter. It may mean if you've got putting an emitter back into the same hole may not be such a good idea. That can give you some leaks. You may need to cut it out, put a straight coupler in, and then put another hole in for your new emitter. Next slide. Let's turn our attention to one of those situations that may appear to be a leak, but is really the result of topography. Installing irrigation on slopes can be tricky. Tubing should be placed across the slope along the contour lines. If the slope is especially steep, increase the distance between the lines as you descend down the slope, especially near the bottom. Emitters should be placed above the plants because water flows downhill. And when you see it, it makes perfect sense. If you've got a particularly steep slope, you may need some extra check valves in the lines. Otherwise, water will drain out the bottom because the pressure above is more than the emitter pressure compensation that's within the valves. It's more than it can handle. So you may think you have a leak, but you really have a different problem, a draining problem. Next slide. Let's summarize what we've talked about tonight. We are still in drought with low water supply in our reservoirs. We need to continue to conserve water in our landscapes and homes. We ask that you monitor your water consumption on a regular basis. Use your water meter or other devices to detect leaks. Use your senses to find those leaks. Listening is especially helpful. Turn off the water to isolate and repair the problem. Recognize that sometimes what you think is a leak is actually a different problem. Regularly check your irrigation tubing and fittings to search for leaks and damage. Monthly is a good place to start. Keep a repair kit on hand to repair leaks as soon as you find them, rather than having to go to the irrigation store and lose your momentum in the meantime. Grow your irrigation with your plants. Move emitters or inline tubing further away from the stems and trunks of your plants, and add emitters or more inline drip tubing. Use the plant canopy to help you with proper placement. Before we leave this presentation, we'd like to introduce you to ways to get help with your irrigation problems. Garden Sense is a partnership between the UC Master Gardener Program of Sonoma County with the Sonoma County Water Agency, Sonoma Water. We have been helping Sonoma County residents reduce water use in their landscapes for 9 years. I'm the current Garden Sense coordinator and work closely with Lauren and Chris from Sonoma Water and others in their department in furthering our mission to reduce water use in Sonoma County landscapes. Next. Garden Sense is a unique program within Master Gardeners. We are the only program where teams of Master Gardeners visit homeowners in person. During our 90-minute visits, we advise and educate residents who are interested in water conserving measures in their landscape. This includes converting or reducing your lawn, converting your spray irrigation to drip, and or upgrading your existing irrigation to conserve water in your landscape. We help you find and address problems such as those described in tonight's presentation. We also advise residents on low water use, climate appropriate plants, and provide landscape ideas and suggestions for how to hydrozone. Last year, we made a record 289 garden sense visits across Sonoma County, and we've made over 1,400 visits since our inception in 2013. Next slide. If you would like to request a Garden Sense visit, you can go to our Master Gardener site, click on the Garden Sense logo, or take a photo of this page with your phone. And Lauren will include the Garden Sense link in her follow-up, and she may have already put it in the chat. Okay, and next slide. And this is about quail, that if you would like to hire someone, choose a landscaper who is quail certified. This means they have received extra training in water efficient irrigation, of which drip irrigation is top of their list. Next slide. Thank you for joining us this evening. We hope you've learned some things that will be useful in your irrigation journey, and now are happy to answer your questions after Lauren takes us through however we're doing the next steps.
Yeah, for sure. Yeah, thank you, Leslie and Chris, for all of this great information. And yeah, we can get started with some of these questions. Looks like we have a few on, you know, types of like tools that people will need. But maybe we can start off by answering the question from Diane, who asks, one of my valves on my controller stays on the whole time. My other 5 valves go through their cycles. How do I get it to cycle on and off normally?
That's a Chris question.
Okay, so Diane, I have some ideas about what's going on. Normally, when you have a valve that is operating when all of the other valves are operating, then it means that that valve is actually linked up to what is called the master valve or a pump start on your irrigation controller. So the valve that's not cooperating correctly, first of all, I would isolate which wire belongs to that valve and see where it's hooked up. So if it is truly not on one of the zones, 1 through whatever, however many zones you have, and it's accidentally on something that says P or MV, would be pump or master valve, those are to trigger something else to happen. Every single time any valve irrigates, that will also come on at the same time. So if your valve is accidentally hooked up to that, then you'll want to move that to where it belongs. There are other possibilities of wires being crossed, but that's the first place I would start.
And then along with valves, since we're on the topic, Roger asks, can you put an anti-drain valve on water line that is higher than, I'm guessing, the original valve?
Yeah, so I think where Roger's going on that one is when we were talking about the anti-siphon valve being too low, and that when it shuts off, water drains out of the vent side of the valve. So you're like, well, I don't want to put my valve like 10 feet in the air, so what am I supposed to do? So, you know, a couple solutions for that is, one, to move the valve to a higher location near where you're going to be irrigating, but sometimes that isn't really practical. So for code purposes, in that case, you should have what's called a, if it's a residence, a double check valve, which is a type of valve that protects the line from any water backflowing. And then you don't have to use an anti-siphon valve. You can use an in-ground valve, and you don't have to worry about that as much. If you do put in an anti-drain valve, in which I'm thinking is a check valve, that's a one-way valve, water only goes one way and doesn't come back, that could be a solution to the problem. It's not a code solution, but it is a solution that would prevent water from coming back and coming out of that valve. That wouldn't really, you know, pass an inspection, but that is the purpose of a check valve, is the water goes one way and doesn't come back. So the next question that we have from Kent while we were, well, Leslie was talking, I was feverishly working in the background to pull up to get some slides ready. I'm going to try to share my screen here and pull up some images for his question, along with some other questions too. So
while Chris is pulling that up, I'll just read aloud the question from Kent. He asks,
okay, great.
Irrigation flow meters I have found have minimum sensitivity of 1 gallon per minute. My drip system zones are as low as 5 gallons per hour. Will flow meters be of much use when the flow is so low?
Okay, so it says it's gonna shut off your screen sharing, so I'm gonna take over for a minute and then we'll come back.
No problem.
Okay, so when we're talking about flow sensors, what I have here is is a picture of a inline flow meter sensor that is used for irrigation purposes, not for your household use. And so finding a flow sensor that will work under your flow conditions is something that needs to be considered usually from the beginning. It's like, which is going to be my lowest flow valve? What should I, which size flow sensor should I purchase? Sometimes there's not a perfect fit. So in this case, this is what one looks like. And let's see if I can get the next one to come up. Here is where one of them is installed, and here is where that particular valve is installed. Here we have a master valve, where I think Diane might have hers hooked up wrong. And then we have this flow sensor. Notice that there's some distance between the flow sensor and other things. They should always have a little distance here. And then what's going to happen here is, should a leak ever happen with any of these valves, this flow sensor will know what's up. It'll be like, hey, this valve is supposed to be operating at this flow and it's not. So it will send a message to the irrigation controller, and then the master valve goes, okay, I'm going to shut things down until we figure out what's going on. So that's kind of the purpose of the master valve and also the flow sensor. So sometimes just trying to get it to calibrate and buy the right one is important. I think you have a link to share in the chat box for that in just a minute. Okay, and so now here's a close-up of this particular flow sensor, because this is a 3/4 inch. It's really, really, really tiny. So you're gonna see as soon as this thing turns on, this black wheel, which was also a leak indicator, will just start flying really fast. So this will actually calibrate really low. And so in the specifications for this particular model, it goes down to 0.2 of a gallon per minute, which happens to be the minimum flow for most irrigation valves is 0.2 of a gallon per minute. So it's basically as low as you're going to get in the industry for that type of valve. Okay, so then I'm going to go ahead and just keep going on that. Hopefully that answers your question, Ken, but that is an issue that we've got to keep track of. So Mary, let's see here. Okay, so Mary asked, are these pressure tools available for sale? So you can make these yourself. You just have to acquire some of these tools. I've got a couple of images of what they look like when you're putting them together. So this is your pressure gauge. I suggest a 60 PSI gauge, because if you have more than 60 pounds of pressure on a drip system, you already have a problem and you need to go out and get yourself a regulator. And you want to be able to read it. You don't want the increments so small that you can't see. And then you have, this is an adapter that goes from a 1/4 inch thread to an 1/8 inch thread. And this is an air compressor gun tip. It's a rubber tip that goes on the end of an air compressor gun tip. So you can kind of Google around for that if you'd like. Another option that I came up with was this one, and this one is actually a helium tip, and I'm excited about this one for a couple of reasons. One, because it's 1/4 inch and you don't need that extra adapter, but also when you take a reading, it'll hold the reading here until you tip the tip of it, and then it squirts water out, and there you go. So either one of those you can make yourself. And Mary, if you have trouble finding any of that stuff, feel free to email me and I could send you some links on where you can find that. And then let's see, Olivia had a question on where to use a Goof plug. So Olivia, it would not be in this situation right here. This is definitely more than a Goof plug. This is called the landscape contractor. This also is not a Goof plug. And the reason for that is because there's a couple of chew marks here. You might get lucky, but honestly, this is probably a job for a coupling where you would cut it. I mean, if you didn't have a coupling, I would definitely try a goof plug first, but that's probably a coupling. Where you might use a goof plug would be in a situation where if you had, this emitter actually is only missing its top, but if it was an actual missing emitter, you can either choose to replace it with a new emitter or put in a goof plug. And if you do put in a goof plug and it leaks, that means you needed a coupling. So then you pull it back, you cut it out and you put in a coupling. And this is what the goof plugs look like. They're two-sided. One is for a baby hole, one is for a bigger hole. So in my experience, if you use a pair of pliers and you hold on to the baby side, you can get that big side in there and then it will stop the leak.
And Chris, this is Leslie. Another instance might be you've decided to make some changes in your garden and you pull out your distribution tubing, your 1/4-inch distribution tubing. You perhaps can use goof plugs in there, right?
Mm-hmm. Yeah, sure. So you just changed your mind, or the plant died, or the emitter clogged, or something like that. That happens with well water. So you could pull the emitter out, put a goof plug in. A lot of times it's better if you have a clogged emitter because of, you know, high iron count well water. Sometimes you're better off to just leave it clogged and put another one in, because then you don't have to deal with it. So that would be where you would use a goof plug. So then we have, let's see here. I thought I had another picture for you. Let's go back up here. No, I don't. Okay, so I'm going to quit sharing here and try to, actually, you know what? I'm going to go ahead and have Leslie, you answer Diane's question. Let's see here.
Okay. Yeah, so Diane asks, can you mix a 1/4 inch inline with bubble emitters on the same distribution line?
Well, this is not a very good idea. You really want to have the same gallons per hour in both. So it sounds like you're maybe talking about having 1/4 inch inline and putting a bubble emitter on the end. Not a very good idea, or even on the same zone. You really want to keep those separate. Chris, any addition for that?
You know, I mean, so yes, I mean, the reason for that is because it's hard to calculate how much rain equivalent is falling here versus here. So yeah. Bubblers tend to be, you know, a rainfall that's a little bit heavier than what the inline emitter tubing is. If you can fine tune that, if there's just like one plant that you have that has this issue and you just need to stab it in there, then you can try it. But keep in mind that it's generally a good idea if you have what they call match precipitation. All of the emitters are performing the same way for one hydrozone.
Now there's a related problem or something you'd want to do with this. And that is, say you've got a whole bunch of 1/2 inch inline drip and it's 1/2 gallon per hour. And you have this plant that's just a little out of the way. And you could go ahead and put some distribution, you know, put a hole in that inline drip and put, you know, again, the same size of emitters, 1/2 gallon per hour around that. Either the emitter right there on the tubing, or with the extended 1/4 inch distribution tubing, spaghetti tubing, would be a good way to do that. And it's about the same emitter rate, same gallons per hour. So it's not the same. It's more finely tuned than putting a bubbler on there.
And Chris, I think this is a question for you. Bruce asks, can I replace the inner works of a pop-up sprinkler without digging out the whole thing?
Yes, you can. Bruce, it'd be interesting to know why. Are you wanting to convert that to something else? Because then Leslie's got all those slides. But if you have one sprinkler that's just not doing its thing, it's damaged, then yes, you should be able to unscrew the cap, pull it off, and what'll be there is a cap, a riser stem, a spring inside if it's just a pop-up sprinkler head. And if that's the only thing wrong with it, then you take that sprinkler down to your local sprinkler store and you say, this thing's causing problems, can I buy a new one? What they're going to sell you is an entirely new one, and hopefully the threads from the one will fit back into the guts of the old one, if that makes sense.
Now, if you're wanting to convert to drip, and there are some caps you can use, that means you don't need to take the whole sprinkler head out. But in our experience at Garden Sense, we find that they're not as good. They tend to leak a little bit, and it's better to go down and take the time and the effort to go down and cap off all the way down at the nipple, down near the PVC.
Okay, it looks like we've got a couple more questions I want to try to get to before we end. There was one talking about valves. Do you have to replace the whole thing? So Jody, yes. So I'm going to share my screen one more time here. And here we go. So here we have in the bottom right-hand corner is this, this valve taken apart. So basically, if you know what valve you have, take some pictures of it. You can go down to the store, and if it's one that's common, even if it's not the same color, sometimes they're green or gray, you can buy a new valve and just replace the guts of the old valve with parts from the new valve. And that way you don't actually have to do any cutting underneath the valve to replace it, if it's an anti-siphon valve. If it is a valve that's in the ground, it's the same, it's kind of the same thing. You would remove the top, put new guts in it, put the new top on it, put good quality new wire connectors on it, and away you go, so that you can avoid that, having to buy a brand new valve.
And I add a couple of comments to this too. Mm-hmm. When I first put my valves in, somehow we got just a little bit of sand in there. And so I had one leaky valve. Okay, this is a brand new valve. This is very irritating for that to happen. And so, but I was able to take the valve apart and discover that little bit of sand and clean it. So if you happen to, it's worthwhile taking that top off the valve and seeing if that's simply what the problem is, cleaning it and putting it back together.
Okay, so let's see here. We've got a couple other things. Let's see. Chris is talking about master valve. Where would I find that valve in relationship to the three valves that are closer together? Okay, so I think what we need to do is, Jody, I need you to send me an email. We've got my, Lauren, can you put that in the chat box for me? And I'll help you out offline a little bit more on that one. But the master valve, where you're going to be finding the issue, is on the actual controller, the timer, and where it's wired to. That's where I think you're going to discover that problem. Okay, and then Roger's asking a question, are we going to discuss replacing emitters with the same, especially pressure compensating? So so basically what Roger's asking is, if I have an emitter that's popped off and I need to put a new one on, do I really need to be too concerned with replacing, you know, like for like? And so I think I need to explain a little bit about pressure compensating. So pressure compensating emitters mean, if you've got, you know, a lower pressure line at the very end and higher pressure at the beginning of the line, that they will still put out the same amount of water, despite the fact that there's more pressure going into the higher side than the lower side. Whereas if you buy some sort of kind of cheapo emitters that are not pressure compensating, they may say that they're a gallon, but if you're not using them in the proper, you know, pressure window, they might actually be putting out 2 gallons or 1.5 gallons. And then if you are on the low end of things, you may be putting out less than 1 gallon. So it's really hard to tell how much water you're actually delivering to each plant. So if you can use pressure compensating emitters, that's great. They don't cost a whole lot more. They have more value to them when you have different slope variations, to where it might be more pressure one end than the other, or you have a really large landscape zone. The smaller zones, there's not a lot of pressure loss, so it doesn't really affect it as much. If you have really cruddy well water, sometimes pressure compensating can be a little bit harder to keep flowing. Okay, I think we have.
There was at least one comment in the chat.
Okay, let's go back to the chat. Okay, great.
From Fritz at 709.
Oh yeah, Fritz. Yes, I saw that. Where'd you go? Was that Q&A? Might have been Q&A.
No, it's in the chat.
Okay.
So trying to. fits with that. So Fritz says that he's found it that it's easier to set up a camera to take interval photos or even a video of the water meter while jiggling various valves to assess total water flow or leakage.
Mhm. Oh, that's great. If you have the ability to do that, then that's fantastic.
And thank you everyone so much for being here tonight. That about wraps up our program and really appreciate you being with us. Thank you so much. Have a good night.